What this new roof was actually a new separate structure from the rest of the existing building. On the engineering side, it was all in a pursuit of how do we make this building as a prefabricated kit of parts that would be built. And then there was a 9'3" deep beam that's 80 feet long. Thank you, Alistair, for the introduction. Hello, everybody, and happy to join today's Wood Solutions webinar and to help provide some educational resources about mass timber, which goes towards Timber Lab's mission to expedite the mainstream adoption of mass timber in the US and why not the world, right? So without further ado, I'll go ahead and get my screen up here so we can start presenting. So today I'm going to share with you about the Portland International Airport project, which is a 9-acre mass timber roof, 400,000 square feet approximately. And it just opened with its phase one. Some of you, if you visited Portland the last month or so, you might have had the opportunity to walk through the airport. I just flew out last week for my first time, so got to experience it as a passenger, which was pretty cool. So a little bit about Timber Lab and what we do. We're a holistic mass timber solutions provider. We do timber engineering, digital construction, strategic procurement, manufacturing, fabrication, factory installation of hardware, and the eventual timber installation on site. A little bit about this project. It took a team of many. There's some stats out there that something about 30,000 people worked on the airport expansion project altogether. That was more than just the roof. It was a whole terminal core revamp at the airport. But specifically as it relates to the roof, the partners on there were the owner, which is the Port of Portland, the architect, which is ZGF, the structural engineer, which was KPFF. The general contractor for the project was a joint venture between Hoffman and Skanska. And as the mass timber trade partner, it started out as Swinnerton, and that's when we were Swinnerton Mass Timber. And during the project, we officially became Timber Lab. And in conjunction with the steel trade partner on the project, which was WW AFCO. So that was the real partnership of people working together to make this roof a reality. Some highlights about the roof are its size, of course, 392,000 gross square feet. The large glulam single span beams of 80 feet long, MPP roof diaphragm that's 2 inches thick, glulam, MPP, and timber frame skylights, MPP parapets, and curbs. So there's a lot of different kinds of mass timber elements within the roof. Some unique highlights about those large beams is that, as a single span member, 80 feet long, it's not only the length, it's the arch. The highest arch inside those beams was 16 feet tall. Our deepest beam was 9'3" deep and 80 feet long. And we also had to put 6-foot long reinforcing screws in some of the beam ends, which we'll share a little bit about later on in the presentation. There were over 1.5 million plus structural fasteners in the project that were installed by a maximum of 35 craft that we had on our site. So a handful of people installing over a million screws, and 10,000 plus hours of mass timber detailing. The project started with manufacturing in 2020, but we started on the project back in 2019 as the mass timber trade partner, helping to get through the design development with the design team and to do a lot of mock-up testing and evaluating the details for the project to make sure this roof can be what it is today. And to talk a little bit about the design, which was designed by ZGF Architects, it really started from a place of how does the airport and the construction team keep this airport operational 100% of the time during construction. It was the port's intent to not affect the operations in any way during this construction. So that meant that you couldn't stick build a roof over the existing building because you'd have a giant crane up there all the time and that would impact flights. And so that's where the idea of creating modules that would slide into place one by one to not disrupt traffic, and that could be done in the middle of the night when planes are not being taken off. What this new roof was actually a new separate structure from the rest of the existing building. The existing building was going to be demoed here. They're going to maintain ticketing, maintain baggage claim and the baggage systems and the MEP system. So all this was getting maintained while also getting upgraded with the new expansion. And this was going to get torn down, a new roof getting moved in, and then a new whole terminal core being built above it. So it's quite a complex project to take on, and it took a lot of meetings and detailing and planning to figure out how to do it. And we played the mass timber part of this building. What the building was prior and after this roof, this roof was made of many different expansions over many decades and had over 1,000 columns inside of it. Today, the roof sits on only 34 columns. So you have 9 acres sitting on only 34 columns, if you can imagine that. On the engineering side, we did a lot of testing at the front end of the project to develop what could be a simple, repeatable connection type. And the engineering for the cassettes would sit on those 34 columns I mentioned, and those columns secured the roof to be seismically isolated from the rest of the building, while at the top of those columns, there's a seismic isolation bearing where the roof can move in up to 22 inches in any direction in isolation of the rest of the building. So it's a pretty unique structural detail that KPF created there. On the engineering side, it was all in a pursuit of how do we make this building as a prefabricated kit of parts that would be built out on the airfield and then broken apart into modules so that it became then modular and then brought back together. And that started with planning out the airfield side where these would be built and creating spaces large enough to build them. So we built the main terminal core on one pad, and then these other pads created the post-security areas that were on the sides of the main core. And the concrete in which it was set on was all built without rebar in it, so that concrete can get recycled and put back into the airport somewhere else later on. And the idea behind doing this was not only to not disrupt operations at the airport, but to minimize the risk of safety incidents, to bring a roof down from what's at its height today of 60 plus feet in some areas inside the terminal with a lot of obstacles to get around. This roof was built at 13 feet off the ground out on the prefab yard. So it made it really easy to access for the craft and made it a much safer condition to work in. So it was like one of the most ideal conditions to work in for craft, not only because it's low, but also because once we got the roof on and we were working on the underside, you're out of the rain for the season, and it was actually a pretty nice place to work at. The manufacturing part of the project's one of the most exciting for me in learning about glulam and how to manufacture really large, complex members like we did on this project. This is the 16-foot member I mentioned. It's 80 feet long with 7-foot, 4-inch deep members at the end, and it's 4 foot deep in the middle. And so this beam was manufactured as a main center beam, and then it had a built-up section on the top and a built-up section on the bottom that got manufactured on it as a secondary process. And then there was a 9'3" deep beam that's 80 feet long, which was huge for a glulam. And what that process entailed was developing the drawings and the plans to get there, but going a step further and actually making laser cut guided sheet metal shapes to help set up the jig in which these were going to be pressed in to ensure we're going to get that exact shape. And following through on those add-on sections, how those sections got cut, then stained, and then this was the mock-up of that install.